Hi, this is Dr. Pello with video 4 of how to take correlations and translate them into latent variable models. So I'm back starting in Amos, and last time we looked at exact solutions with with 3 variables. And now we're going to move out to what if we have 4 variables accounting for a latent variable. So I'm going to construct a latent variable here. Let's start off. I go over to this box here and say I need a data file from my documents, and here's the data file that I'm picking up. Say OK, and now it should give me the variable names in there. Doing just a simple latent variable. So I grab this icon, 1, 2, 3, 4. 4 measures for this. I'm going to rotate this around to the right. And then I'm going to take items assessing what Dr. Wood calls authentic living. He has 4 items for that, and I'm going to pull those 4 items over there. So 4 items to measure the construct. I'm going to go ahead and name this latent variable authentic living, shorthanded. I'm going to use these plugins to name the rest of the unobserved variables, which are my errors. It would also name this one as F1 if I hadn't named it. My estimation strategy, I'm going to stick with, remember that usually comes with maximum likelihood, but I'm sticking with unweighted least squares to show you how things work. And for my output, I want the standardized estimates and sample moments, implied moments, residual moments, what's left over. And that should do it. Go over to this box and calculate estimates. You notice when the estimates show up over here, they're now under this tab. So this tab is for setting up the model to be run. And if I'm going to change this model, if I said, I need to go back and change this model, I want to click this tab. Once I'm looking at the results, I go over to this tab. Once you're in this tab, you can choose to look at your unstandardized estimates or your standardized estimates. It's basically said that it achieved finding a minimum of the sums of the errors squared. Again, when I'm over, though before I run, this box would not be lit up, but it is lit up now, showing me that it has output. And I can look at the notes for the model, and it shows that I have 2 degrees of freedom. Shows the implied correlations and shows the standardized residual covariances, basically indicating that these implied correlations didn't exactly map onto these correlations. Let's see if we can see where there's a difference. Here's a 0.639 between 9 and 1. And our model implied that the correlation was 0.625. So it was off a little bit. Okay. So we're picking up some degree of error in our models. Still, this model fits extremely well. When you're doing unweighted least squares, you don't get the full complement of fit indices, but this, in fact, most of my favorite indices are not here. But for example, the TLI, the CFI, we would get if we did maximum likelihood. But these right here, 1 and 0.99, the closer those are to 1, the better fitting the model is. The closer this RMR is to 0, the better fitting the model is. It's not perfectly fitting, but it's doing a pretty good job, or an excellent job. But it's a simple model. So simple model should do a good job. We shouldn't be real surprised by that. Okay. That's the Amos version. Here's the model that I was trying to estimate. A picture of it brought over into Excel. Here's the correlation matrix that I started with. I have 1, 2, 3, 4, 5, 6 correlations. And what I'm going to do is take these 6 correlations and put them under here where it says actual correlations. So 0.624 is the correlation between item 1 and item 8. Item 1 is here, item 8 is here. It would be reproduced by the model by going down path A and then up back through path B. So A times B should give me a 0.624. My next correlation is 0.639. My next correlation over here is 0.567. And then I've already filled in some of these other correlations, 0.708, 0.864, and 0.659. Now, I need to come up with a system for reproducing these, and it's simple tracing rules. The correlation between this first variable and the second one should be A times B. So my implied correlations are the correlations given by the tracing rules. Implied correlations are those that are reproduced using tracing rules based upon the model that is supposed to explain the actual correlations. And so I would write these equals this factor loading, which is A, times this factor loading, which is B, and I get 0.25 right now. If I change that to 0.6, you notice that changes there. The next one is A through C. So I've labeled these A, B, C, D for the paths, and these are the multiplications. We'll call them tracings, right? So over here is the tracing of A through C. So A times C. And then it would go A times D. Those are already in there. The last one down over here is C times D. I'll redo that one. C times D. Okay. Now, over here, just like before, I've specified how far off I am. So I take the original correlation minus the implied correlation, square that amount, and since I have 6 correlations to be reproduced, And I have 6 tracings giving me 6 implied correlations. This is how far I'm off. Now you'll remember how we used the solver last time. I would go again and say if you don't have the solver installed, you go to File and then Options. So I needed more down over here. Options and Add-ins. Excel add-ins, go. And make sure that you, usually these won't be clicked to start off with. Go ahead and click your analysis toolpacks and your solver add-in. Hit OK. And now the solver should be installed. And so now we should be able to go Data, Solver, and click on this one here. Tell it to minimize this, get that error as low as possible by changing the factor loadings. The factor loadings are going to be the values that come up for each of the tracings. And then solve, hit OK, and it's gotten the error down pretty dang far, and it's given me loadings of 0.738, 0.85, 0.84, 0.78. These are the same estimates that we obtained using Amos with unweighted least squares estimation. So what you're doing is you're getting the weightings, the ones, the variables with the highest weight. So B and C tend to be weighted high. So apparently they're the predictors that have the least error associated with them. They're kind of doing the best job of measuring authentic living, where there's a little bit more error in A and D. And this model is giving us the optimal weighting of these for reducing error, the error associated with any one item as it forms an unobserved variable, but one that now hypothetically explains the correlation matrix, explains the data. Models are designed to explain the data. So factor loadings, a set of tracings, given us implied correlations. We match those to the actual correlations, see how much error, minimize the error. We can do that in Excel, and ta-da, we have estimated a latent variable. Thanks a bunch.